I did my OChem engineering project on the molecule urea. Urea is a very versatile and interesting compound. It is naturally created inside our bodies as a method of nitrogen excretion because ammonia is toxic to the body, and turning it into urea makes it safer. It is also one of the most largely industrially synthesized compounds, mainly because of its use as a fertilizer. Urea can also be used in many other products like plastics and cleaners, but it can also be used to remove pollutants from the exhaust fumes of cars and can even be used to diagnose medical problems in patients. The biggest impact that the lab synthesis of urea, which was discovered by Friedrich Waller, had was on the agricultural industry. Since it was mainly used as a fertilizer, the ability to mass produce the compound and make it available to nearly every farmer around the world greatly increased the ability of farmers to produce food and ultimately started the Green Revolution. One potential negative result of the use of urea is that when it is used irresponsibly by farmers, it can actually be harmful to the plants and soil. Now on to the synthesis of urea. Urea is actually the first organic compound to be synthesized from inorganic compounds. This was believed to be impossible at the time Waller made this discovery in 1828 because most scientists believed in the concept of vitalism, and that organic compounds could only be made by other organic compounds. Waller made this groundbreaking discovery entirely on accident when he incorrectly predicted the products of a reaction of silver cyanate with ammonium chloride. He thought a double replacement reaction would occur. However, he ended up with an isomer of his predicted ammonium cyanate, which was urea. Here is the mechanism for Waller's reaction, which I won't go over because it's not the main synthesis for urea, but here it is to look at. Since Waller's original discovery, other reactions have been discovered to produce urea, the most widely used being the Bazarov reaction, which is essentially a two-step reaction involving ammonia and carbon dioxide. It is also the same way that our bodies produce it in the urea cycle. The reaction is overall exothermic, and although the reaction takes place at high temperatures and pressures, it requires cooling in order to maintain reaction stability. So here's the mechanism for Bazarov's reaction, which starts with the shuffling of electrons to generate a carbocation on the CO2, as well as an NH2 anion known as azanide. The azanide then donates an electron pair and attaches to the CO2's carbon. This molecule forms a salt with the ammonium, creating the ammonium carbamate intermediate. Next, the single-bonded oxygen is protonated by the ammonium, which turns into ammonia. Then the ammonia donates an electron pair and attaches to the central carbon atom and forces the electrons from the oxygen double bond to move up the oxygen. Finally, a hydrogen from the ammonia substituent bonds to the OH group, producing a water molecule that detaches, freeing the other oxygen to reform its double bond. The final products are urea and water. Alright, now I will go over the industrial production of urea. There is a lot going on in this diagram, but first we'll start in the lower left corner with the raw materials to start the reaction. Industrial plants use the aforementioned Bazarov reaction to create urea, so ammonia and carbon dioxide are needed. These are often produced on-site from other materials, where a reforming process can produce a source of carbon dioxide as well as a source of hydrogen, which gets mixed with nitrogen pumped from the air to produce ammonia. Once the CO2 and NH3 have been produced, they are mixed in a high heat and pressure reaction chamber that must be cooled due to the exothermic reaction that occurs, producing a molten ammonium carbamate intermediate. The unreacted materials get recycled and the ammonium carbamate flows into an evaporator where it is turned into molten urea and water. The water gets recycled and the urea goes into a granulator to get turned into fertilizer pellets. Finally, the urea pellets go through strainers to make sure the pellet size is consistent, and they are tested to ensure the purity is optimal for its intended use. And finally, here are the sources I used throughout my project.